Data visualization essentially makes data easier to understand. So it's the representation of numerical data in charts, graphs, images, and sometimes even video. There are many software applications to facilitate the process of creating data visualizations, and sometimes what we call data dashboards, which are interfaces that allow us to see different visual representations of data, to try different things. It's very much a discovery process. There's a quotation by an American statistician and mathematician named John Tukey, and it's that the greatest value of a picture is that it forces us to notice what we never expected to see. And I really like that, because that's, for me, and I think for many people, what characterizes data visualization is that it's a discovery process. You take large, unwieldy data sets that are hard to work with, and you can, in a single picture, begin to look and explore and analyze that data. But at the same time, it's very much an intentional manipulation. And so in trying to represent that data in different visual forms, you might see different things, or maybe even obscure things. I think one thing that's important to think about when we talk about data visualization is some other fields that are closely related to data visualization, like information visualization, or InfoVis, and data storytelling, and also data design. These are sort of other fields. If we think about taking numerical data, working it into visualizations, and then taking those visual representations and perhaps creating stories with them, or making InfoVises or information visualizations for news or for media or for papers. But we have to understand that this is one story. There may be many stories in the data. At one point in history, data visualization was something that was done often by statisticians and mathematicians. But we live in an era of big and open data. There's so much data around us that's generated by everything in every industry. And so data visualization has become an indispensable tool to understand that data. Data was once really hard to access, and so of course stats was a place where it was generated and collected, but now it's collected everywhere.
Can you give us some examples?
Well, an early example that I really like is by an epidemiologist from London in the 1800s, John Snow. And in this one example, there was a cholera outbreak, and I believe at the time that they thought that this was that it was airborne. But what John Snow did was map, in something that was very much an early geospatial visualization, map all the cases of cholera onto a map of London. And by doing that, it was very easy to see that most of the cases were all happening around their water supply, a water pump that was in the central part of that area. So it became very easy to see through this geospatial visualization what was causing the outbreak, that it wasn't airborne, that it was the water supply.
Can you explain a bit the process of data visualization?
So, in a nutshell, the process of creating a visualization involves transforming numerical data into a visual form. Often numerical data or data that's stored is stored in the form of spreadsheets, so columns and rows of data. So the steps involved are basically taking that numerical data, editing it, wrangling it, working it into a form in which it can be imported into a software application. And depending on the software application, it might require different formats. For example, a very basic or rudimentary visualization tool, but still very powerful, is Microsoft Excel, which is a spreadsheet, but it provides a way of taking that data that's in the rows and columns and looking at it in the form of graphs and charts. But every different visualization tool or application might require the data to be in different forms, and that treating of the data from its raw spreadsheet form into the form that it can be imported could be quite simple, as in the case with Excel, or it could be quite complicated. for example, working with network-based visualization tools like Gephi. There might be actually some coding involved in getting it from its raw state into the state that it can be visualized. So once it's imported into that tool, then you can begin looking at different visualizations of it. Another application called Tableau provides a way of creating more like data dashboards that I mentioned before. And when it imports data, it imports it from a raw spreadsheet form, such as Excel or something called comma-separated values, into a database, which is what enables it the tool Tableau to be able to create dashboards and different ways of seeing the data.
Can you explain what data literacy is?
Sure, yeah. So as citizens, we're frequently presented with data and information visualizations online and in different publications. And it's important for us to understand how these visual representations of data can simplify the complexity of the data or only tell a partial story. Because of that, data visualization and InfoVis can either intentionally or unintentionally tell stories that are either incomplete or incorrect. In the data-driven world that we live in today, it's important for just about everyone to be able to read, understand, and even critique visual representations of data as information. Being data literate can take this one step further and involve the ability to create our own data visualizations. And that might be learning a tool such as Tableau or even Microsoft Excel.
Can you give an example?
Sure. A great example is by a Belgian designer, Karim Douib, who works at a company called Jetpack. And what Karim did was create a visualization of the 2020 US election results. There were a number of election maps, so geospatial visualizations that were showing the results of the election, but coloring a map according to the geographic size of the voting region. And of course, the geographic size of the voting region doesn't correspond to the number of voters that are in that region. So what Karim did is create a visualization that essentially morphs geospatial visualization of land size to population size. And those two different representations of that election result are very different and tell very different stories. So this is a great example of how a representation of data in a visual form can tell a very different story depending on how it's done.